Look up at the night sky. It's a vast, star-studded canvas. Each point of light holds secrets. We are drawn to these mysteries. Humans have always been curious. We long to understand the universe and our place within it. This yearning for knowledge is ancient. Our ancestors painted images on cave walls. They charted the stars. These early astronomers made a profound connection. The cosmos influenced life on Earth. This realization was the start of our journey. We began to explore the universe and its secrets. Imagine the universe in its earliest moments. It was an unimaginably hot, dense point. Then about 13.8 billion years ago, it happened. The Big Bang. This event marked the beginning of everything. The universe expanded rapidly. From that tiny point, space and time unfolded. Energy transformed into matter. Subatomic particles formed. Gravity drew them together. The first stars ignited, ending the cosmic dark ages. The Big Bang wasn't an explosion in space. It was the expansion of space itself. Imagine a tiny balloon suddenly inflating. That's the universe growing from an infinitesimal point to an incomprehensible vastness. In the first fraction of a second, everything was chaos. Energy crackled and swirled. But within this maelstrom, order began to emerge. The universe cooled as it expanded. This cooling allowed fundamental forces to separate. Gravity, the weakest but most far-reaching force, took hold. Electromagnetism and the nuclear forces also came into play. These forces governed the interactions of the universe's tiniest constituents. The universe was now a swirling soup of quarks, electrons, and other particles. The universe was now a vast, expanding sea of hydrogen and helium, but within this seemingly uniform soup, gravity was at work. Tiny variations in density, perhaps caused by quantum fluctuations in the early universe, provided the seeds for structure formation. Gravity pulled matter together, amplifying these tiny differences. Over millions of years, gravity drew clouds of hydrogen and helium together. These clouds became denser and hotter. Eventually, the pressure and temperature at their cores became so intense that nuclear fusion ignited. The first stars were born. These early stars were massive, hundreds of times larger than our sun. They burned brightly, but their lives were short. Supernova explosions also disrupted the surrounding gas, triggering the formation of even more stars. Gravity continued to draw matter together on larger and larger scales. Smaller clumps of stars merged to form larger collections. Over billions of years, galaxies emerged as islands of stars in the vast cosmic ocean. Galaxies come in a variety of shapes and sizes. Some are spiral galaxies like our own Milky Way, with graceful arms of stars and gas. Others are elliptical galaxies, smooth and round, with little gas and dust. And still others are irregular galaxies, their shapes sculpted by collisions and interactions with their neighbors. Billions of years ago, our planet was a very different place. The early Earth was a hot volcanic world, constantly bombarded by asteroids and comets. The atmosphere was thick with noxious gases, and oceans of molten rock covered much of the surface. It was a hostile and unforgiving environment, yet somewhere in this primordial chaos, life emerged. The exact details of how life arose from non-living matter remain a mystery. However, scientists believe that life may have originated in volcanic vents on the ocean floor. These vents spew out chemicals from the Earth's interior, providing energy and nutrients for primitive life forms. For billions of years, single-celled organisms were the only life on Earth. Then, about 3.5 billion years ago, something remarkable happened. Photosynthesis evolved. This process allowed organisms to harness energy from sunlight and convert it into chemical energy. Photosynthesis transformed life on Earth. Early photosynthetic organisms released oxygen as a byproduct of their metabolism. Oxygen, toxic to many early life forms, gradually accumulated in the atmosphere. This great oxidation event was a pivotal moment in Earth's history. Life continued to evolve and diversify. From the oceans, life spread to land, colonizing every corner of the planet. Plants took root, transforming the landscape and releasing oxygen into the atmosphere. Animals followed, evolving a dazzling array of forms and adaptations. About 540 million years ago, during the Cambrian explosion, life underwent a dramatic burst of diversification. In a relatively short period, a stunning array of new body plans and species emerged, laying the foundation for the diversity of life we see today. For millennia, humans observed the heavens. They tracked the movements of stars and planets. They noticed patterns, cycles repeating with predictable rhythm. But it wasn't until the 17th century that someone explained these celestial ballets. That someone was Isaac Newton. Newton, an English physicist and mathematician, proposed his laws of motion and universal gravitation. These laws were revolutionary. They explained why objects fall to the ground, why planets orbit the sun, and why the moon causes tides. Newton's work unified heaven and earth. He showed that the same laws govern both. Newton's laws were incredibly successful in explaining the universe. They worked perfectly for most everyday phenomena. However, as scientists delved deeper into the nature of light and gravity, they discovered cracks in Newton's framework. A new revolution in physics was on the horizon in the early 20th century. Albert Einstein, a German-born theoretical physicist, proposed his theory of relativity. Einstein's theory challenged our fundamental understanding of space, time, gravity, and the universe itself. While physicists were busy unraveling the laws of the cosmos, biologists were unlocking the secrets of life itself. In 1953, James Watson and Francis Crick, with the crucial contribution of Rosalind Franklin, made a groundbreaking discovery that would revolutionize our understanding of biology: the structure of DNA. Deoxyribonucleic acid, or DNA, is a complex molecule found in the nucleus of every cell. It carries the genetic instructions for the development, functioning, growth, and reproduction of all known organisms and many viruses. Watson and Crick discovered that DNA has a double helix structure resembling a twisted ladder. We've journeyed from the Big Bang to the birth of stars, witnessing the incredible process of cosmic evolution, from the initial explosion that created the universe to the formation of galaxies, stars, and planets. The cosmos has been a theater of constant change and wonder. We've seen life emerge on Earth and evolve into complex beings, adapting to diverse environments and creating intricate ecosystems. From the simplest single-celled organisms to the vast diversity of flora and fauna, life on Earth is a testament to the power of evolution. We've witnessed groundbreaking discoveries that reshaped our understanding of the universe. Telescopes and observatories have allowed us to peer deeper into space, revealing the secrets of distant stars and galaxies. Now we turn inward to reflect on what these discoveries mean for us. We contemplate the profound philosophical implications of these scientific revelations. What does it mean to be a part of such a vast and ancient universe? How do these discoveries influence our understanding of existence and our place within the cosmos? For centuries, humans believed Earth was the center of the universe, a notion that shaped our worldview and our place in the cosmos. Ancient astronomers used rudimentary instruments to map the skies, creating models that placed our planet at the heart of everything. Copernicus challenged this view, proposing a heliocentric model with the sun at the center. This revolutionary idea was met with resistance, but eventually transformed our understanding of the solar system and our place within it. This shift in perspective was profound, but it was just the beginning. The heliocentric model paved the way for future discoveries, leading us to understand that our solar system is just a tiny part of a much larger galaxy. We now know that our sun is just one of billions of stars in the Milky Way galaxy, each with its own potential for planets and possibly life. The vastness of our galaxy is a humbling reminder of our small place in the grand scheme of things. And the Milky Way is just one of billions of galaxies in the observable universe. Each galaxy contains millions or even billions of stars, making the universe an almost incomprehensibly vast expanse. Our journey through the cosmos has only just begun, and there is still so much more to discover. The vastness of the universe raises profound questions about our place in it. Are we alone in the cosmos, or do other intelligent beings gaze up at the same stars, pondering the same questions? The search for extraterrestrial life is one of the most compelling scientific endeavors of our time. If we were to find evidence of life beyond Earth, it would revolutionize our understanding of our place in the universe. The discovery of life elsewhere would suggest that life is not a cosmic fluke, but rather an inevitable consequence of the laws of physics and chemistry. It would mean that the universe is teeming with life, a symphony of diversity and complexity beyond our wildest imaginations. The universe is full of mysteries, vast unknowns waiting to be explored. The more we discover, the more we realize how much we don't know. This realization is not discouraging, but rather invigorating. It fuels our curiosity, our desire to push the boundaries of knowledge and explore the unknown. We live in an age of remarkable scientific discovery. We are building more powerful telescopes, sending probes to distant planets and moons, and developing new technologies to study the universe in unprecedented detail. We're on the verge of answering some of the biggest questions in science. What is the universe made of? How did it begin? Are we alone? We stand at the edge of a new era of exploration, a time when the boundaries of our known world are expanding beyond the confines of our planet. Just as our ancestors set sail across uncharted seas, driven by curiosity and the desire to discover new lands, we are now preparing to venture beyond Earth to explore the final frontier, space. The dream of space travel, once confined to the realms of science fiction and the imaginations of dreamers, is steadily becoming a reality through relentless innovation and determination. We have already sent humans into orbit, landed on the moon, and taken those first monumental steps that have paved the way for future exploration. We have built a permanent outpost in space, the International Space Station, where scientists and astronauts from around the globe collaborate and conduct groundbreaking research. But this is just the beginning. The dawn of a new era is upon us, filled with endless possibilities and uncharted territories waiting to be explored. Space agencies around the world, along with private companies, are developing ambitious plans for future missions, pushing the boundaries of what we thought was possible. We're going back to the moon, this time to stay, with the intention of establishing a sustainable human presence. Establishing a permanent lunar base will serve as a stepping stone for further exploration, providing a launch pad for missions deeper into our solar system. We are setting our sights on Mars, the red planet, with its mysterious landscapes and potential for past life, with the goal of sending humans there within our lifetime. We are on the brink of making history once again, as we take the next giant leap for mankind. Beyond the challenges and opportunities of space travel lies a universe of infinite possibilities. The universe is vast, far larger and more mysterious than we can imagine. It holds secrets beyond our current comprehension, mysteries that beckon us to explore, to question, to discover. We may find evidence of extraterrestrial life, perhaps in the form of microbial life on Mars or Europa, or perhaps as intelligent signals from distant star systems. Such a discovery would fundamentally alter our understanding of life in the universe and our place within it. We might discover new laws of physics, new forms of energy, or even new dimensions beyond our current perception. Our journey through the cosmos has been nothing short of remarkable, a testament to human curiosity and resilience. We started with the Big Bang, a colossal explosion that set the universe into motion, witnessing the birth of stars and galaxies, each a marvel of cosmic creation. We saw life emerge on Earth, from the mighty dinosaurs to early humans who gazed at the sky with wonder, pondering their place in the vast expanse. We've traced humanity's quest to understand the universe, from ancient stargazers who carved their observations into stone, to modern-day scientists peering through powerful telescopes. Each discovery, each new piece of knowledge, adds to the grand tapestry of the cosmos, painting a picture of a universe that is both intricate and awe-inspiring. The universe is vast and mysterious, full of questions yet to be answered, and landscapes that inspire a sense of wonder and exploration. But this is not daunting, it's thrilling. It ignites a spark within us, a desire to uncover the unknown and venture into the depths of space. It fuels our curiosity, our desire to explore, to learn, to push the boundaries of human knowledge, whether in a lab, a cave, or the vastness of space. We are a species driven by a thirst for understanding, constantly seeking to expand our horizons and grasp the mysteries of the universe. It's in our DNA, passed down from those first humans who looked up at the stars and asked, "What's out there?" This endless voyage continues, fueled by our insatiable curiosity and the timeless quest for knowledge.